This is the fifth and final video in this series on hypothesis testing, brought to you by the Stat Cave. Let's look at an example or two with proportions and using hypothesis testing on proportions. The Bazinga Football League's Players Union claims that 72% of the players suffer hearing loss from crowd noise. In a random sample of 298 BFL players, 229 showed hearing loss. At an alpha of 0.05, is there enough evidence to support the BFL Players Union's claim? This screams proportion. All right? They claim that 72%. Okay? Now, what do you think we're going to do? First, we're going to get the null and the alternative. More than 72%. So, greater than 72%. So, the claim is the alternative. P is greater than 0.72. What is the complement of that? It would be the null here is less than or equal to 0.72. So the claim is the alternative hypothesis. The null hypothesis always contains equality. Note we are using P here for proportion rather than a Greek M for the mean, population mean. We're looking at the true population proportion. Now, on the hypothesis testing spreadsheet, we're going to go down to the tab that says proportion. Okay? At this point, we are going to enter our information. The proportion hypothesis testing sheet is a little bit different. I put in my sample size, 298. Number of successes, or that's the number of ones that actually showed hearing loss. In this case, it's not necessarily a success to have hearing loss, but it is what you're counting. Okay, so 229 out of 298. Do not fool with the yellow. That just gives you a sample proportion. It's 229 divided by 298. Only enter in green cells. Notice we only put 4 things here. The alpha says is 0.05 in this problem. The hypothesized value, they claim that more than, claims that 72%. Okay, 72%? More than 72 claim. Ooh, it's more than 72 is what they're claiming. More than 72. So, remember, all right, what we have here. The claim is that more than 72. It's a right-tailed test, since the alternative, or the P, is greater than 0.72. So it's pointing to the right. So it's a right-tailed test. All right, so I put in the 0.72. So, all right, greater than 0.72 is my alternative. My null would be that it's less than or equal to 0.72. So I'm going to reject the null. And by rejecting the null, I am actually going to say what? By rejecting the null, we are supporting the union's claiming, saying there is enough evidence to support the claim that the true proportion of BFL football players who suffer from hearing loss due to crowd noise is greater than 72%. All right, let's look at another one. In a study based on responses from 1,200 high school math teachers, it was determined that 73% were overworked. Use a 0.06 significance level to test the claim that fewer than 75% of the teachers are overworked. Note the exact number. They don't tell me how many teachers out of the 1,200, but they tell me 73%. So I can easily get that number by multiplying 0.73 times 1,200. I also could have typed 0.73 times 1,200 in the success box on the spreadsheet. We'll do that in just a second. And it wouldn't be that difficult to do. All right. So, my claim that the claim is that fewer than 75% are overworked. So the claim is less than 0.75, fewer than 75%, so less than 0.75. My claim is my alternative. The complement of that would be that it's greater than or equal to 75% or 0.75. So I go to my spreadsheet. I put in 1200 for the sample size, 876 for the number of successes, 0.06 for alpha. The hypothesized value said greater than 75% or less than it was less than 75%. So there. Now, since alpha was less than 75%, or not alpha, but since the alternative hypothesis was less than 75%, the null was that it's greater than or equal to 75. So I look to the right of greater than or equal to. I reject it. So again, here, by rejecting the null, I'm going to be saying that there is evidence to support the claim. Now let's do this one actually in the spreadsheet. Let me show you a couple of things. Okay, again, this is proportion, population proportion, hypothesis test. I want to click the proportion tab. The sample size on this one was 1200. The actual number of successes, if I wanted to, I could have just as easily said, okay, they said 73%, so I could have, in this cell, typed equals 0.73 times, remember an asterisk is times in Excel, times 1200, all right? 73%, you tell there, but don't mess with the yellow cells. Alpha, what was my alpha here? At a 0.06 level of significance. The hypothesized value was 75%, so I would enter 0.75. Now, all right, I've got a z-value, test statistic of negative 1.6. Remember what we had. They were claiming that it was less than 75%, so the null would be that it's greater than or equal to. I'm going to reject that, and by rejecting the null, I'm saying there is enough evidence to accept the claim that it was less than 75%. I wish each and every one of the students that come to this site the best. Wherever you come from, wherever you've been, always use your textbook. Always use everything that your instructor offers you. Seek more help. Statistics is a fun subject. Again, these spreadsheets are available in the Stat Cave. I will put the address in the comments section or the description of this video.